to record the session today. So if anyone has to leave early or anything, it will be recorded and we'll send it around to everyone who has signed up. I'd say by tomorrow. So I just want to welcome everyone. We've have a great number of people there on already and some questions coming through already as well, which is great to see. I just want to welcome our expert speaker today, Ian Donnelly. Ian is a qualified plumber, a registered gas installer, and has qualifications in oil heating systems and heat pump installations as well. He's a quality inspector on domestic SEI grant aided schemes and is now a quality assurance auditor. Welcome, Ian, and thanks so much for joining us. Oh, I think you might be on mute, are you? Just unmute down.
I'm back in. Thank you, Louise. Thank you very much.
Thanks, Ian. So today I'm just going to quickly, this is going to be about a half an hour for everyone. We're going to hopefully get through as many questions as we can. Down in the bottom right-hand corner, there's a Q&A box for everyone that you can just pop your question into. And that you just send it to both the hosts or the panelists. Yes, it is the panelists. And you can't see the questions, but I'm going to read them out and we'll get through as many as we can. So most of you here today have signed up to SEI's Home Energy Plan. We hope you're finding it useful. You're coming to the end of week 1 now. So our focus this week has been on how to reduce your energy use for heating. We hope you found the device and resources we provided on this topic kind of useful. Ian will touch again on some of the no cost and low cost actions you can take before we jump straight into your burning questions and all things related to heat. So first of all, Ian, can I just ask you for some of the most impactful low cost or no cost actions that we can all take to reduce our energy use for heating this winter?
I suppose with the rise in energy costs at the moment, there is a little bit of panic setting in as well, and I'm sure in the future it is going to settle. And people think that they don't have maybe enough money for retrofitting. Because they can be quite expensive. So people generally sort of have to make do with what they have. So they might have gas heating. They might already have heat pump installations. The fabric of the building a lot of the time gets overlooked when people talk about heating and energy costs. So the fabric of the building is what the fabric is actually made up of. So when you talk about wall insulation, attic insulation, double glaze, treble glaze, even single glaze windows, floor insulation, this is what's called the fabric of the building. And as I said, people a lot of the time overlook the fabric, and they I think everyone knows from growing up, everybody talked about leaving the immersion on and the panic that created, and lagging jackets on cylinders. And these are all sort of page 1 of the energy saving manual, I suppose. And everyone's grown up with that, so they are aware of it. But it does make sense that you're heating a big vat of water, and if you didn't have a lagging jacket, then the heat is escaping almost as quick as it's being created. And these are like the most simple ways of saving energy. And if you were to go
so number 1, lagging jacket. That's obviously, I think most people have a lagging jacket? It's inexpensive to get it sorted if you don't.
Yeah, they would do. Our new installations would have factory fitted insulated cylinders, and they're almost like flasks for your hot water, and they are highly efficient. And they're much better than a lagging jacket. But if you had no lagging jacket or no insulation on your hot water cylinder, it'd be quite costly just to change it to an insulated cylinder. So like a cheap one would be to go to a local DIY and get a lagging jacket, and it would be a good start. With regards to immersion heaters are they're fine, and there is a panic there because they're generally 2 to 3 kilowatts, so they use a lot of energy when they're on. Now they do have built-in thermostats that are generally set around 60-65 degrees, and the water should stop heating when it hits that point. So it should save you energy when it hits that point. But when that temperature drops,
if you leave on your immersion, Ian, then so just say you head off for the weekend, you leave on your immersion. Is it costing you all the time, or
it is costing you because as the water cools down, the immersion will kick in again. So what they recommend, if you can afford it, and you can get an electrician to fit a timer onto the immersion so that you can set the time for that immersion to come on. Or you can set even boost buttons that have like a half an hour, a 1 hour, 2 hour function. Now, most people with central heating, when the central heating is on, that will heat the hot water. Because the hot water is, you could treat it as almost an extra radiator. So when
Yeah.
the heating's on, you can choose some heating systems, it's all on, so everything heats, and some you can control zones and stuff like that. If you have them, if you're lucky enough to have them, there are other ways to save energy. And that sort of brings me on to, as part of that heating system, that zoned heating systems, how they work, I suppose, is that you have a gas oil boiler, and you ask the boiler to come on. So all the boiler knows is to heat water, and then a circulating pump will take that water to radiators, underfloor heaters, hot water cylinders. And then as the water returns to the boiler, it gets reheated again and then sent out again. So there's a thermostat on the boiler that you set, and the boiler might cut off, or well, it will cut off when it reaches that set temperature. But that's not, it doesn't tell the boiler what the house needs. So you could be overheating the house and wasting a lot of energy. So
Okay.
when people talk about heating controls, what it means is that there's a thermostat inside the home, and it could be you could have a downstairs zone or an upstairs zone, or even just one space zone. And what that thermostat does is when it reaches the set temperature, it tells the boiler that the house is warm enough, and it stops wasting fuel or wasting energy. And then you can have a thermostat on the hot water cylinder as well, which would be a separate zone. And when that reaches the set temperature, it tells the boiler to stop consuming fuel. So they're not massively expensive to get controls retrofitted to the
Okay.
central heating system, and there are grants available. I don't want to push
Yes.
grants here,
Yes.
because that's not what this
No,
is.
I know we're talking about the low cost, but it is probably one of the, if you were starting somewhere and you did want to invest a little bit, the
Yeah,
heating
yeah.
controls
So
grant is about €700, isn't it?
yeah, €700 for
Yeah.
the controls grant. Now that sort of leads me on to what I talked about earlier, which was heat retention. So
Mm.
most of your heat is going to rise up, because that's what hot air does. So everyone knows about attic insulation, but people think when they have rows of attic insulation between the joists in their attic that their attic is insulated. Now it is insulated to an extent, and it will deflect some of the heat loss back into the house. But the standard today is 300 millimeters, which is
Mm.
12 inches, I suppose, in old money. And so
Yeah.
that's the standard of attic insulation that you'd be looking to get. And there are grants
Okay.
available for attic insulation, and you can get them as a standalone measure. So, like in a mid-terrace house, it's €1,200 is the grant. And now they're partial payment grants, so people hear grant and they think it's going to cover the cost. So unfortunately, for these grants, they're partial payment, but they do go a long way. And when you go
Yeah.
through
You
SCAI
shop
grant
around as well.
schemes, yeah, and when you go through
Yeah.
grant schemes, they're registered contractors with the SCAI, and we do quality checks on them, we do inspections on their work, so the quality is quite high as well. So it's
Yeah.
just one thing. But if you were to go basic and you had a central heating system, I'd advise to have controls on the heating system and to have attic insulation as a minimum.
Yeah,
And that's
because it's
before. So
30% if your attic is, it's 30% of the heat that's been lost through the attic if
yeah,
it's not
yeah,
insulated. Yeah.
yeah. Approximately 30% will go through the roof and through the walls. Is how it's what the research has shown. Um, a lot of um, a lot of people think they need new windows. When in actual
Yes, I
fact,
was going to ask you this.
yeah, and people like new windows, and it's always on the tip of people's tongues when you're talking about energy saving. But if you do look at the heat loss calculations, it's between 10 and 15% goes out the window, so it's a massive cost. So I've heard prices of somewhere between 9 and 12,000 euro for window replacements in like a semi-detached home, and they're recent prices, so
Okay.
prices have gone up. But if you think of 15% goes out there, and like getting the attic insulated would be a fraction of that cost. So what your windows might actually need, if they're already double glazed, might be just the servicing of the openings, and maybe there's drafts coming in through the openings of the window, and maybe the rubber seal's not engaged correctly, or the hinges need to be adjusted. So that's another place you can go, just to check that maybe get someone in to maintain the windows could be the answer in that
Okay,
instance as well.
perfect. Yeah,
And
so you
then if
might't
you,
always need to replace them. So it might just be a case of that you're just getting them fixed a little bit up.
yeah. Now the
Yeah.
gas does there's an argon gas within the glazing panels, and that's what deflects the heat back into to the home. Sometimes that gas can get out eventually, and if anyone ever sees their window has condensation on the inside, that's usually a sign the gas is gone. So unfortunately, in that instance, you'd have to replace that glass panel to for it to be effective again.
Is
So
that
that,
always the case, Ian? So that's a question we get asked a good bit. So if you see insulation on the inside, should you be nervous? Is it always that the fact that the windows
yeah, if you see
need to be
condensation on the
replaced? Yeah.
inside, I'd say the gas has escaped from the panel.
Okay.
Now, I think there is companies that can regas them and find where the leak is.
Okay.
There is ways to do that, but I don't know the costing of replacing panels and filling them, but these are options. So like all them three things I mentioned are sort of that's where I'd start if I was starting from zero in a home.
Yeah.
And then you can if you had some money, there's lots of options like getting the walls insulated. If you've a cavity, you can get it pumped. External wall insulation, or people call it the wrap. That's the one that goes on the outside. There's internal wall insulation, and that's a composite board that sticks to the inside that has a vapor barrier. Um, there's also floor insulation. You can get. There's no grants towards floor insulation on the single grants, but through the one-stop shop, SEAI do give funding towards the likes of floor insulation. And then you go into heat pumps, solar PV, solar thermal is one that heats the water. And so your boiler doesn't have to do that work for in the summertime, let's say. And then in the winter time, on a sunny day, there will be energy still being stored in the water, and your boiler won't have to work as hard to bring it up to that. And then, as I
Yeah,
said,
we get asked a lot, Ian, just about the heat pumps, why we don't give grants for unless you have reached a certain standard with, for heat loss. So,
yeah,
and
so they
just to
call it
explain to people that yeah.
yeah, they call it a heat loss index. And so when you get a BER done, which is a building energy rating, you get a heat loss index from that report. So if it's greater than 2, it means that there's significant sort of heat loss from the home. So
Yeah.
heat pumps work on uh, taking the heat from the air. So it drives it over an evaporator coil, which has a refrigerant gas in it, and that's what extracts the heat from the air. And then so it's just like the principle of a boiler is that you heat water inside a heat exchanger, and then a circulating pump takes that to radiators, underfloor heating cylinders. That's the principle of all wet
Yeah.
heating systems. So all the heat pumps, so that heat pump just extracts the heat from the air with the technologies that a heat pump has, and then that heat gets taken into the home to heat the home. Now, with a heat pump, unfortunately, it can't reach the temperatures that a fossil fuel boiler can heat. Like the up to 70 degrees and stuff like that. They generally reach 40, 45 degrees. So when that temperature of water is going through a radiator, you won't have that same blast of heat. You know, when someone comes in from being out in the cold, they stand at the radiator and stuff. You won't have that
Yeah.
blast of heat that people are used to. So there's your behavior has to change if you have a heat pump system. So you need to sort of preempt when the heating sessions are going to be. You don't come in from the
Yeah.
cold and say it's a bit chilly, I'm going to stick a boost on. Unfortunately, it doesn't work like that with a heat pump. You need to,
It's just
you need to,
always warm.
yeah. But so back to your point that you made, Louise, that because the temperature from a heat pump is low, if the heat loss index is high in the home, then the heat is escaping before it can even be retained. And so what will happen
Okay.
is your energy bills will be very, very high to run a heat pump, and it won't be efficient. Um,
Brilliant.
so that's why for a heat pump, we what we talk about, as I mentioned at the start, was fabric, and a fabric first approach is always what we like to tackle. So that would be wall insulation, attic insulation, windows, just to make sure that
That's
HLI
first. Yeah.
is 2 or
Yeah.
less. And then your heat pump will definitely be efficient. So people talk about a COP, so that's the coefficient of performance of the heat pump. And some of these heat pumps have COPs of 3 and 4. So what that means, for every 1 kilowatt of electrical energy that goes in, you could be getting 3 to 4 kilowatts of heat energy coming back out of the heat pump, and that's what makes them 400% efficient. And when you hear people saying 300% efficient, 400% efficient, that's what that means. And that
Okay,
if you put when you
brilliant.
put 1 kilowatt in and get 3 out, it's 300% efficient. Yeah.
Super.
So
Right, Ian, we might get to some of the questions because I'm just conscious that we have been chatting and there's loads of questions coming through. I'm just
okay.
going to start at the top. So, and if we can't get to all the questions, we will do up an FAQ sheet, which will circulate tomorrow as well. So fresh not. So first question in, I live in a house that's over 60 years old with gas central heating. Attic is insulated with fiberglass and I cannot afford retrofitting, etc. How can I keep my house warm and be able to pay my energy bills? It's difficult with bills soaring rapidly. So I think this is a very common question.
Yeah, it is difficult. I think I probably answered maybe some of these questions
Yeah,
at the start. So the basics will be to make sure your hot water cylinder is insulated so that there's not heat loss. You can also insulate the pipe work in the hot press, or if you have any heat and pipe work in uninsulated areas, that would help save energy too. Um, um, when someone can't afford retrofitting, they may be able to afford small things like lengths of pipe insulation and stuff like that. So any uninsulated pipes, that's how you would save in energy on your heating system. And then with regards to the attic, as I said, sometimes people think because they have that little bit of insulation in the attic, that the attic is insulated. But as I said, 300 millimeters or 12 inches is the standard, and most of your heat rises up. So if you can get your attic up to that standard, and as I mentioned, there is grants available, and you can get a list of the contractors on SEAO's website,
brilliant. Yeah,
and then
I'll
check your
share that with
windows.
everyone. Yeah,
Yeah, so I think
super.
I touched on most of that at the start because, as I said, it is the common sort of questions from homes. So that'd
Brilliant.
be
And
where I
we'll
would
share
start.
that with everyone tomorrow, all the links and everything. So,
Yeah.
so the next question, are heat pumps fitted outside the house or the
They are.
building?
So he put. If anyone's ever been on holidays, you'll see an air conditioning unit maybe for your apartment. That's what a heat pump looks like. So an air conditioning unit, its job is to take the heat from inside and expel it to outside. So a heat pump works in reverse. So it's taking the heat energy from the air and sending it into the home. So an air to water heat pump will look like that, and it is set outside. Then you have ground source heat pumps, and what they are is there's a coil that's buried underground, so it's either laid out in a grid or it goes down in a core. It can go down up to 80 foot into the ground, and that extracts the heat energy from the earth. So, but the unit for that would be indoors; it wouldn't be outdoors. And then you have air-to-air heat pumps, which are probably the ones you see on holidays that look like uh, 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 air conditioning system, but they bring heat into the home, and that'd be that outdoor unit I talked about, and then an indoor panel that sort of blows the air through air into the
Yeah,
home. So
once you kind of know what to look for, you start to see them everywhere.
yeah, and then there's exhaust air heat pumps, which is a bit like heat recovery, and they'd be within the building as well. And they're included as part of the ventilation system of the house and extracts the heat from the air that's being expelled from the house and send it back in. So they're sort of all the options for heat pumps. They'd be indoors as well.
Yeah, perfect. Um, please explain the types of electric radiators and which are the most efficient.
I suppose the types are a lot of people might know the storage heaters.
Yes.
The thing with electricity is 100% efficient, which sounds great. It sounds really good. It's 100% efficient. But what that means is for every 1 kilowatt of heat energy or electrical energy you put in, you'll get 1 kilowatt of heat energy back out. So that's generally how electric heating works. So what you have is the storage heaters, and what they do is during the night rates, they'd heat bricks that are within the unit, and then during the day they're set to release that heat energy over the time. So they'd be the most efficient because you'd be heating them on a night rate of electricity is generally how they work. And then you have ones that have oil inside, and they'd be heated with an element within, and you can have smart controls on them, so you can do it on demand. You can operate them remotely. They'd have room thermostats, so when the room heats reaches certain temperatures, it will tell the radiator to shut down, and bits and pieces like that. So it's hard to say which is the best,
Yeah.
because they're all 100% efficient. But again, it'd be down to the fabric of the building. If that heat is escaping quickly, then it's going to cost you more to keep the room warm. But they'd reach high temperatures as well. It wouldn't be like the heat pump with low temperatures. So you would get a blast of heat from an electric heater. And
Yeah,
then
that's true.
you can have fan assisted heaters as well. So as the heat's coming off, there'd be a fan that would encourage what's called convection currents. And that would work more like a central heating radiator from a wet system. It'd be very similar to that.
Okay, thanks, Ian. Um, would there be any advantage in changing over to gas? So a gas tank, not a line. We currently have oil central heating.
If you currently have it sort of depends on your budget.
Mm.
Gas is a cleaner fuel, and it's what we call a transition fuel. So, if you are getting your home heat pump ready, um, then it's a transition fuel. So that would mean you're sort of ready that when that time came that you were going to switch to a heat pump, the wet side of the system would probably already be up to standard. Oil systems, I suppose generally the boiler's outside, takes up a bit of space, or it's out in a boiler house. It might not be as neat, but it
Mm.
depends on your budget. If you have an oil system, servicing it regularly, if it's a condensing boiler, it's obviously more efficient. Well, when people talk about efficiencies, what they sometimes people don't understand what it means. So when someone says that a boiler is 92% efficient, sort of a real simple way to look at it would be that for every €100 you spend on that heating system, €8 of that is escaping from the home and not giving you any energy. That's a real simple way to look at it. So older boilers are 80%, maybe less, maybe a little bit more.
Okay.
Yeah, but um, yeah, it really depends because the cost of oil rises, the cost of gas rises, and it sort of changes. So either way, you're going to have bulk storage, because you'll either have an oil tank or you'll have the gas tank. But gas is just a little bit cleaner. That's all. But
Okay.
yeah.
Super. What does the temperature showing on your boiler mean? For example, 60 degrees, and what should it be set to?
Right. So the boiler is the temperature that you've set the boiler to heat to. So um, the heat is transferred through radiators or through a coil in the cylinder. Now we'd always recommend that you're heating your water to at least 60 degrees. That's for Legionnaires protection. If there's any
Okay.
Legionnaires bacteria in the water, that will just safeguard you against that. So if you're setting it to 60, then eventually you will be able to transfer that 60 degrees to you through the coil in your cylinder. And then the temperature on the radiators as well will get up around that. So between 60 and 65 degrees is what you'd set your boiler to be at. And if you have a combi boiler, if anyone knows what a combination boiler means, that the boiler will heat the water as well. You wouldn't set that to 60 degrees because that's the water that comes out at the taps, at the outlets. So you'd be looking more between maybe about 40 degrees to 45 for that. If but that's what it
Okay.
means. And so 60 degrees is fine. If it's set to 60, if you set sometimes you see an eco setting on a boiler. If you set it to eco, it's generally that will be the default temperature because you have to get
60.
hot water up to
Okay.
60.
So if anyone has it any higher, you can turn it down to 60.
You can turn it down to 60, but the boilers, if there's controls involved, you won't lose too much energy, if it is set a little bit higher than 60. Yeah.
Okay.
Um, I'd probably
Perfect.
advise between 60 and 65 because you need to transfer the energy to the stored water to get that to 60.
Okay. Super. Should I use the heating to heat up the water, so the central heating, instead of the immersion? Is it cheaper? Do we
Um,
know?
Yeah, I suppose because gas rates are going up as well as electricity at the moment, so it's very hard to tell. But in the winter time, your heating will be on anyway. And I might have mentioned earlier that the cylinder is basically another radiator, so it's just like adding one more radiator onto the system. If your boiler is already up to temperature, then it'd be much more cost effective to have the boiler heating the water. In the summertime, it would depend on what your rates are at the time for gas
Yeah.
and electricity. If you had a night rate electricity, you could set the immersion to come on in them night rate hours between sort of 2 in the morning and 5, or 2 and 7. I forget which. I think it might be 2 and 5. But you could set it to heat at that, and then you'd have your hot water for the day in the summertime. But I suppose there's a few ways to do it, and it does depend on cost at the time. But certainly, if your central heating is on, that would be the way I'd heat the water.
Brilliant. I'm thinking of changing to a combi boiler. Is this a good move? I don't use hot water that much as I have an electric shower and it's just me in the house. Does it cost to keep the water hot?
Right, so combi boiler, you can have a little thermal store within them of water, but generally it's heat on demand, so it will heat the water that you're using. They can be a good answer in apartments, but looking at the future is going to be the likes of heat pumps. So you won't be getting your home heat pump ready with a combination boiler
Yeah, okay.
because
Yeah,
to have a heat pump, you're going to have a store of water again. So that would mean getting a hot water cylinder back in. Um, but they are good systems and they are efficient because you're only heating the water that you're using. It depends on your space, your budget, your plans for the future. They're sort of the questions you just need to
super.
ask yourself.
Just what you mentioned earlier about servicing the windows, someone is just asking who would do that? Who would they get in touch with?
Some window companies have
Window companies.
a lot of
Yeah,
them have a servicing sort of department, and they can even come out and check them, and they might tell you no, or they might just say you just need to replace the rubber seals. This is how much it will cost. Um, yeah, so just if you even have a local window company, just give them a ring and ask them do they have a servicing service, and they'll send somebody out.
okay, perfect. Someone said to me, is it better to keep your boiler on all of the time at a lower temperature? Is that correct?
Yeah, it can be. If we talked about the heat loss index, if you've a well insulated
Mm.
home, it's definitely the way to go. And on the continent in Europe, you'll find that in the winter time, they'll set the thermostats at 18, 19 degrees, and the heating might be on 24/7. And it will only come on when the house has dropped in temperature. But generally, they're well insulated homes. If you have a fossil fuel system like gas or oil, and and not a well insulated house or a very drafty house, you're probably going to look for that blast of heat, and then have that controlled by a thermostat, and that's generally how it would work. But if your house is well insulated,
Okay.
it should be more efficient because the system's already warm, the boiler's already hot.
Okay, we have so many questions, and I'm just conscious that we're now at the half past mark, but I'm just going to try and fly through another couple. And anyone we don't get to, as I said, we will answer for you and send around in an FAQ sheet tomorrow. This one is to do with heat pumps. My HLI is 1.87. What size heat pump do I need? One contractor tells me 10 kilowatts, another one tells me 14 kilowatts.
Right, so sizing is based on room by room calculations. And what they'll do is they'll find the heat loss of that room and the volume of that room, and they'll size a heat emitter for that. So a heat emitter would be either a steel radiator or maybe
Mm.
an aluminium radiator. And so there'll be a certain amount of kilowatts that are required to heat that room. So what they do is they'll add up all the rooms together and the kilowatts that are required to heat each room and to heat the water system. And then they'll add there'll be some compensation added on for losses, and that's how they size the heat pump. So I can't answer the question what size should my heat pump be,
Yeah.
because it's based on what kilowatts are required to heat the home and what size radiators are in place.
Um, and question here, do I need to change the radiators if they're old? Will this make a difference?
Um, Yeah, but so some people, if you look at the back of your radiator, you'll see there's little fins, like a zigzag of fins on the back. So all the radiators don't
Mm.
have them. So what the fins do
Yeah.
is they increase the surface area of the radiator. So that actually gives you more of an output on the radiator. So if you don't have them fins, like an older radiator that doesn't have them, it wouldn't be as efficient. So it would be an advantage to change that radiator in that instance. But sometimes there's a service that some plumbing companies do called a power flush system. And what there might
Yes.
be,
Yeah.
yeah, people talk about sludge in their heating system, and what sludge is liquefied rust. So the radiators are metallic, so that they do rust over time. Once there's oxygen in the water, it will oxygenate and rust will happen. So sludge happens, and that can affect the performance of a radiator. And what a power flush does is it sends the heating system water through a magnetic filter system with pumps. and it flushes it through, and all the sludge will stick to them magnets and clear out the system, and that could be the answer to making your system more efficient. Um, if the radiators have been cleaned out and the pipes have been cleaned out. Now there is a cost to that, of course, and you can ring around to get quotes. But it could be well worth it, especially if you feel like the bottom half of your radiators don't heat and bits and pieces like that, or the radiators feel real patchy, so the patches of the radiators are cold and stuff. That would definitely mean that there's sludge in there and the system needs to be cleaned.
Okay. I think heat pumps are on all night, so would that not make it very warm in bedrooms? It's hard to sleep in warm bedrooms. Definitely find that as well, but I don't think that's the case, is it?
No, they do have to. They do run for long parts of the day. Or you can, if as I said, if you're on night rate electricity, you can set them at night. If you have solar panels, solar electric panels on the roof, they can coincide with the times that the heat pump runs and stuff like that to save energy in that instance. With regards to bedrooms, you can have there'll be room stats anyway for the system, telling the system when a certain zone has reached this a desired temperature, and that will shut that zone down. And when the heat pump senses that the demand isn't there, it will ramp down. So it might still be running, but it will ramp down, so it's not using as much energy, and it might keep ticking over. And there's also items called thermostatic radiator valves that can be installed to radiators. Um, um, and you set them to a temperature, and when that room reaches that temperature, it will what it does is it restricts the flow to that radiator,
Oh,
and it was
brilliant. Yeah.
yeah. So it's just there's a
Because we
bimetal
recommend
strip
about the 16 degrees, isn't it, in bedrooms kind of. That's
in somewhere between 15 and 18
yeah.
in a bedroom,
Okay.
depending on
Preference.
I
Yeah.
suppose how you feel the heat. And then in the living areas, they reckon somewhere between sort of 18 and 20. 19, I think, is
Yeah.
the sweet spot.
Yeah,
But some
19.
yeah,
Yeah.
but everyone feels temperature different. Myself and my
Definitely.
wife.
Yeah.
Myself and my wife could probably do with separate houses in the winter time, with the temperature I like and what she likes. But that's just human behavior, I suppose.
Okay. Definitely.
Yeah.
I'm just going to take two last questions, Ian, and then, as I said, we'll answer all of them for you guys tomorrow. So my home was built in 2004. We've had the walls and attic pumped. The heating is underfloor in some areas, with the rest of the rooms using radiators. We live on an exposed site in the west of Ireland. There is some leakage around the windows and doors, but it's not too bad. The house has a BER of B3. Would this be suitable for a heat pump?
So
Hard to know, I
B3,
suppose. Yeah.
yeah, it's hard to know. Like B3 means you're probably almost there anyway. But the heat
Yeah.
pump, yeah. So you need to find out what the HLI is. So you need to get a building energy rating done. Now it's a specific type of energy rating done. Um, so it's a technical assessment, that's what it's called. And there's a list of technical assessors on the SEO's website. But he'll do a building energy rating. There's a grant towards that, and
Hmm.
they'll let you know what you need, or he or she, sorry, they'll let you know what you need to get done in the home to bring it to that HLI, for it to be heat pump ready. Now, um, some installers might tell you, oh, I'll whip out your oil boiler and I'll put in a heat pump, no problem. It can be dangerous and it can be costly if the home is not going to retain that low temperature heat. And because you have underfloor, you are off to a really good start. So underfloor is ideal for low temperature systems. So even if you have gas or oil and you have an underfloor system, there'll be a mixing valve that makes sure that 65-degree temperature doesn't actually go through the underfloor. It will reduce it to 45 before it goes through. And the reason for that is you don't want tiles cracking and the slab cracking of concrete with that intense heat. But what happens is the concrete absorbs the heat that's going through the underfloor system. There's insulation underneath it, so the heat can only rise. So it's like a thermal star, and what'll happen is that heat will rise over time. So because you have underfloor
Yeah.
heating, it's ideal for a heat pump. Obviously that would have to be assessed. Um, but the technical assessment, it's very important. You find out the HLI of the home to make sure that it is heat pump suitable. So that'd be my
Yeah, I think
advice.
we've had a lot of questions just with people wondering about, is their home suitable? So that's the first step. Technical assessor, list on the website, and they will tell you.
Yeah, yeah, that's it. Now
Yeah.
there is, unfortunately, there is a cost to these things. But if you're considering heat pumps, then that would probably highlight to me that maybe you do have a budget for a good upgrade, and this would definitely be the way to go, because if your HLI is coming in at 3.5 or 4, then the technical assessor will advise you on what needs to be done, as well as getting the heat pump. So what you might have to do this and get the heat pump, and then you won't have them massive electricity bills because the system's not efficient.
One more question. Is it a false economy to turn off the rads in the bedrooms or other rooms that we're not using? Do these rooms then take the heat from the rest of the house?
Yeah, there is a little theory there that cold spaces can draw warm air towards them. So
Okay.
yeah, so this is sort of where TRV is. Remember I talked about the thermostatic radiator valves? This is where
Yeah.
these come in, because they have settings from 1 to 5, and you can set them to a frost setting. So when a room gets lower than 4 degrees, it will open that valve. So if the heating is on, some heat will pass through. So some people set their thermostatic radiator valves to number 1 in the rooms they don't use, so that there's always the room's always tepid anyway. That it's never cold, and that can be a way to reduce that. But if you've got seals on a door and they're completely isolated from the rest of the house, there'd be no need to have a radiator on.
Yeah, and I think it's that idea of only heating it when you need it as well. You know, if you're not in those rooms,
Yeah,
lots of people maybe have a spare room that they only use at Christmas or something. Yeah, probably turn it off.
but some heat's gonna rise. So if you have the heating on downstairs and you have an upstairs in the home, the heat is gonna rise up to these cold bedrooms. So
Yeah.
so having maybe some heat in them bedrooms will deflect that heat back down into the space you're actually in. So, that's another way of looking at it too.
Final question. I live in an 80s built 3-bedroom semi. Do you think we should have a BER done just to guide us as to what we need done? Or do we just start with the basics,
Um,
such as controls?
I suppose it depends on your budget. Um, if nothing, if it's an 80s home and there hasn't really been any major renovations done to it, there is a scheme on SEAI called the One Stop Shop. You'll see the information for that on the website. Again, I don't want to push grants here or anything like that.
Yeah, no,
But
of course, yeah.
One Stop Shop is done through people like ESB, Electric Ireland,
There's a
and
list of them on
yeah,
the website.
and there's a list of them there. And what they'll do is they'll go out and assess the home, and they'll tell you exactly what you need to do, and they'll get your house to what we call a minimum of a B2, which is the energy rating. And there's lots of grants available, but with a one-stop shop, you'll have a project coordinator, and they'll take care of everything. That's how it works. So it might be something to make a phone call, but if I had an 80s house that had nothing done to it, I think that's the road. If I had a budget, if I had some savings, that I think that's the roads I'd probably go down. Yeah.
Yeah. And actually, someone was just asking there that why isn't there more one-stop shops available? So this is just a scheme that has come in this year, and there's more being added all the time.
Yeah, so
But there is a high demand. Yeah.
yeah, there is a background to One Stop Shop. So there was schemes called Deep Retrofit, which were pilot schemes. Then that became the home renovations, and now it's called One Stop Shop. So they've sort of been trialing it. So it's getting bigger every year, and so the more popular it gets, I'd say, and the more successful it becomes, the more contractors will get involved. So um, what SEAI need is contractors to be on the panel and put themselves forward. So when anyone sees success in a certain industry or a certain section of an industry, you can be sure that more people will want to get involved. So the more popular it gets, the more demand it gets. I'd say the easier it will be to apply for them schemes.
Brilliant. Ian, I think we'll leave it there because I'd say we could keep you all day. There's so many questions coming in for you. We'll definitely have to get you back. Thanks to everyone who has asked such insightful questions. As I said, this has been recorded, and what we'll do is we will answer any of the questions that we didn't get, and we'll share them all with you tomorrow. Ian, thank you so much. Is there anything else you wanted to touch on before we leave, or?
No, I think that's it. I think I'm okay.
All right. Thank you so much. You've been an absolute joy and really informative and interesting as well. Thanks a million, Ian. All right,
Okay,
thanks everyone.
thanks
Have a lovely
everybody.
day, and we'll be back next week with another webinar, and we'll be talking all about energy efficient appliances. So we'll be sending out an email to everyone as well. So that'll be week 2, and that's all to do with appliances as well. So keep an eye out for that in your inbox. And this will have a link to the video as well. All right, thanks everyone. Thanks, Ian.
Bye bye.